So now I'm going to cover some of the newer exam questions that came out in 2023. So first off, I want to go over Newton's method. So this is a Newton's method question from the sample exam in 2023. And it says, Newton's method is being used to approximate the non-zero x-intercept of the function with the equation blah. An initial estimate of x0 equals 1 is used. Which one of the following gives the first estimate that would correctly approximate the intercept to 3 decimal places? And we've got a bunch of things there. Okay, so we want to find the first approximate x-intercept to 3 decimal places. So we may as well find out what the what the actual intercept is. So I'm just going to solve this equation up here equaling 0 on my CAS. And that's going to give me 0 or 1.90365. And given we're looking for the non-zero x-intercept, I'm going to get rid of this bad boy, and we know what we're looking for. This is the basic formula of Newton's method. If you're unfamiliar with it, I highly recommend you check out some of my video tutorials on it. It explains it very, very simply. If you don't have access to those, well, let's just see if you can follow along. So on the calculator, I would define f of x equals x minus the function, this thing here, so copy and paste that, divided by its derivative. And so we know the first estimate is x equals 1. So I'm going to do f of 1 equals 9. And that's going to give me the next estimate, which is going to be 9. And then I'm going to sub that back into here. And that's going to give me 6.05, which is going to be my next estimate. And I sub that back into the equation to get my next estimate. And then I do it again and again and again. And I keep doing that until I get to this thing here where you can actually see that this value is pretty much the same as this. It's correct to more than 3 decimal places, actually. So pretty happy with that. And that's actually x8. So that means that the answer is actually going to be C. So bisection method and pseudocode. All right, so consider the algorithm below, which uses the bisection method to estimate the solution to an equation in the form f of x equals 0. So we've got our inputs and defining and all that sort of stuff. Again, if you aren't fully familiar with pseudocode, highly recommend checking out my video tutorials on that. Very much will simplify it for you. But given that, the algorithm implemented is as follows: bisection, and then we've got sine x, 3, 2, and 5. So we pretty much want to define all of these little parameters into here. And so f of x equals sine x. And we know f of a times f of b is larger than 0. So in this case, a and b is going to be 3 and 5. So sine 3 times sine 5 equals this. So that's not going to be invalid. And so we're going to assign 0 to I. And then while I is smaller than the max, which in this case is going to be 2, what we want to do is assign a plus b divided by 2 to mid. So in this case, a and b is 3 and 5. So add those together, divided by 2, and that gives us 4. Then we know that the mid, if the mid doesn't equal 0, which it doesn't, then we're not going to return mid, but we're going to do f of a times f of mid. We chuck that in. So we've got a, which is 3. We figured that up right up here. And mid we got before. This equals negative 0.107. This is smaller than 0. So that means we're going to assign this to b. And then we're going to add another 1 to I. So that's going to give us 1. And while I is less than 2, we're going to keep on doing this. So we're going to go back to that mid formula. So in this case, it's going to be 3 plus 4 divided by 2, because b is now 4. And that gives us 3.5. Okay, and sine 3 times sine 4 equals this. And then if we find out what b is going to be 3.5, because we've already assigned that. and then we add 1, as we do down here, to the previous one, which gives us 2. This is going to be D, because which value would return when the algorithm is implemented as given? Because now we are going, okay, we've reached the max of this, and so we know that it's actually going to be 3.5. Pseudocode and Newton's method. One way of implementing Newton's method using pseudocode with a tolerance level of 0.001 is shown below. The pseudocode is incomplete with 2 missing lines indicated by an empty box. See that empty box? There it is. All right, so tolerance level is basically the accuracy of how much it changes from each step. So an example, if we had x4 equals 2.345 to x5 equaling 2.344, that would be 0.001 because there's only 0.001 difference between those two things. We've got our good old Newton's method equation here. And return just means to give the value. So if we look at these different things up here, if next minus previous x is smaller than 0.001, then return previous x. We want to know a tolerance level to be 0.001. We don't know if the value will be getting larger or smaller. So for example, x4 equaling this to x5, that would be a tolerance level of 1. But if it was x4 here to here, that would also be a tolerance level of 1. So we want to know basically x5 minus x4 is either going to be 0.01 or negative 0.01. So somewhere between those two things. So if we look over at all of these, pretty much the only one that does that is E. So we've got the next x value, which in my example is this, minus the previous one, and that's going to give us pretty much the same sort of idea. Trapezium rule in pseudocode. The algorithm below described in pseudocode estimates the value of a definite integral using the trapezium rule. Consider the algorithm implemented with the following inputs. We've got the following inputs. I've basically just copied and pasted that up here. So we want to define this. So we've got h equals b minus a, so that's going to be 3 minus 1 over n, which in this case is going to be 10, so it gives us 0.2. Then we want to sum fa and fb, so we do that and we end up with this value. Then x, we're going to assign a plus h, and so that's going to equal 1 plus 0.2 because we figured out h before. And then we want to assign 1 to I. So while I is smaller than n, we want to do all of this stuff. So in this case, n is 10. So we're going to sum the previous sum plus 2 times f of x. So here's our previous sum plus 2 times f of x. That gives us this. We're going to assign x plus h. So we figured out our x before. And up there's our h. So we're going to assign that to x. And I, pretty much just going to add 1 to I. It was 1 before. We're going to add 2. And so now because we're looking after one iteration, this has now been done. And therefore, we know the answer is going to be 1.43. And so that's going to be answer C. 3 variable simultaneous equations. So which of the following correctly describes the general solution of the system of linear equations given above? So x equals k, because we've got that for all of them. So we may as well accept that that's the truth. And we just want to sub this into either equation. So let's start with the first one. So that's going to be x minus 2y equals 3. Rearranging in terms of y means we'll be minusing k from both sides, and we could get rid of the negative as well, divide by 2. So y is going to be k minus 3 on 2. But I could also write that like this. It's just half of k minus 3. So that's either going to be C or D, because it's not going to be these, because that's plus, that's plus, that's plus. So let's try this next equation. So we now know what y is, so we'll sub that in. So 2 times that minus z equals 4. That's just from above. And so if we rearrange in terms of z, we can just minus 4 both sides and plus z from both sides, and we end up with this. And if we look at that, k minus 3 minus 4, minus 3 minus 4 gives us minus 7. So very clearly, she's going to be D. And I hope that helps. I've got plenty more resources at MathsMethods.com.au. I went over these super quickly, I know, If you need more information on it, do check out the free resources. They're going to help you out a lot, and I hope you have a good day.